Good morning, everyone. Welcome, and thank you all for joining us for this session today. We're excited to tell you about how Manchester Airports Group, or MAG, are applying Agentic AI so all of our flights can leave on time. And quick show of hands, do we have any frequent flyers in the room? Yeah, lots of you. Most of you probably used an airport to get here. Then I'm sure you'll all agree, this is the ideal scenario when flying. You arrive at airport security an hour before your flight's due to take off, and you sail straight through with no delays. We're all just looking to get through security as quickly as possible so we can start relaxing in the departure lounge or getting down to some productive work, whether you're traveling for business or for leisure. However, whilst MAG have an outstanding record of customer service in the airport, dealing with unexpected logistical challenges is a daily occurrence. And how frustrating is it for the passenger when your airport experience is not a smooth one and your flights are delayed due to operational issues?
Now, imagine you're the line manager of the security line. It's the week before Christmas. It seems like the entire world is trying to travel somewhere. And all of a sudden, someone calls up. It's one of your employees, and they won't be able to make it in for their shift. And all of a sudden, you have the entire line to manage, and you also need to find a replacement for the single employee that can't make it in. How stressful?
My name's Tom Chester. I'm a senior AI strategist at AWS, and I've been working with MAG over the past year to help shape their AI vision. I'm joined by my teammate Margarita and Steve from MAG. And today, we'll give you the context on the challenges that MAG are facing and outline the vision they saw to apply AI to reduce operational complexity. We'll also cover why we have chosen Agentic AI specifically as a solution to this problem. Finally, we'll take you through a technical deep dive of how we helped MAG get started on this journey by building their first use case of many, which focuses on the challenge of rostering shift workers for critical airport functions. With over 1,000 flights per day leaving from MAG's airports, you can imagine the operational challenges they have going on behind the scenes to keep things running smoothly. Many of you probably also work for companies with complex internal processes. Today, we'll share some of the practical lessons that MAG learned from applying Agentic AI to these challenges, with actionable insights you can take forward to your own AI initiatives. From a technical perspective, the solution we've built uses Amazon Bedrock Agent Core, which I'm sure lots of you will have heard about in the keynotes. It's our primary service for deploying and operating AI agents securely and at scale. And as this is an L300 session, we'll be getting into a lot of technical depth. So Steve, let's get started.
Great, thanks, Tom. So, why are you here? I guess a big thank you for your time. You'll have heard a lot already this week about Agentic, and I'm going to set some of the context for how we operate at the airport, and then we'll dive into some more of that technical detail later on. Really excited to share this part of the story with you guys. It's not the beginning, so this is actually a hat trick. This is the third time that MAG are presenting at reInvent. We've also got solutions in place. Val, for example, our AI assistant supporting passengers, and we're also teaming AI with computer vision to determine how we can turn around aircraft on the stand in a more efficient way. My role is looking after our enterprise systems. So that's the stuff that doesn't keep the airplanes in the air, but is still equally as important. So finance, procurement, HR, payroll, workflow and automation, and also the digital colleague workplace. So a lot of this is going to be focused around how we can improve our colleagues' experiences rather than necessarily the passengers or our end customers. So quick background into who are MAG. So UK-based, but global presence. We've got 3 airports. We're the largest airport group in the UK. And we also have an arm of the business that's called Cavu that focuses on travel tech and services. So our Cavu team are focused on building a platform to improve our passenger experience around selling products like lounge bookings, car parking, and fast track through security. Now, we've got some pretty ambitious strategic aspirations, and I guess that's coupled with the fact that there's a significant amount of operational complexity that we also have to deal with across our airport base. We've got around 9,000 staff, but many, many more, 40,000 or so, operating on our campuses across the airports in the UK. So our aim is to provide a seamless experience for our passengers, an industry-leading airport experience. Now, sounds pretty simple, but actually there's an understandable amount of hard work and management of complexity that goes into achieving the KPI that you see on screen there. So our aim is to provide a frictionless yet secure journey for our passengers through security, and maintaining that level of service takes a lot of monitoring, I guess, of all of the different components that come together. And it doesn't always go smoothly. Quick show of hands for anyone that has flown in this week that their journey wasn't quite as smooth through their airports as expected. Okay, a couple of hands. I actually surprised myself. I got here so quick, I beat my luggage by 2 hours. That's interesting, isn't it? The service that an airline and airport provide means that me and my luggage arrived at Harry Reid 2 hours apart. So it's things like that that passengers just view as a hygiene factor. And you know, the particular use case that we're going to come on to dive into some technical detail around is just the first foray, I guess. There's many other use cases that we can apply this to. So, cast your mind back to the example I just gave there around security. Behind the scenes, there's lots of management of operational complexity. We've grown as an airport group over time. COVID was also a period of time that significantly impacted us. You know, only about 1% to 2% of flights were going globally at that time, mainly for cargo rather than for passengers. And it's meant that there's a significant amount of complexity that we need to deal with in the airport. Also consider this, there's a number of different parties and partners that come together. So there's MAG staff, there's also Border Force, there's our airline partners, there's ground handlers. All of these come together to deliver a service that you as a passenger may just consider as you know, a seamless journey. And the final point to mention is that passenger safety and security is priority. So in order for us to prioritize that, it often leads to higher operational costs. So this was the opportunity for us. Now, this is the more exciting bit that I really want to talk to you about. And we are already a good way along this journey. And the opportunity for us is huge. So it's now Thursday morning. AI and agentic is not going to be a new topic that you've heard about at this point in time throughout the week, but we are going to go into a lot more technical detail around how we've applied that. It's certainly no longer a dream, it's definitely a reality, and I hope that this customer story and some of the lessons that we've learned along the way is really useful for you guys to consider, to learn from, and I'm really happy to take any questions as well at the end of the session if you've got any thoughts or queries about how we've applied that. So our vision is to create a single, unified experience for our colleagues, powered by agents, removing a significant amount of the complexity in order to deliver value for MAG. And there's a host of different use cases that we could apply this to. The particular ones that we've decided to focus on initially are shown on the screen, but there are going to be many, many more that we will discover along the way. Tom's going to tell us a little bit more about how and why we've chosen agentic, and then we'll go into the technical detail.
Now, perhaps some of the challenges that Steve has shared are resonating with you, and you're starting to think about operational complexity and technical debt in your own organizations. MAG is certainly not alone in this regard. It's something we hear time and time again from our customers at AWS. Whilst your company may not be coordinating airport security or delivering passengers' baggage, every company has its own operational processes. But with a vision as bold as Agentic AI to control the airport, where do you start? Many processes in the airport are high risk and involve critical customer touchpoints. And it's an environment where passenger safety and security is non-negotiable. So MAG had to get started on this journey by finding the right use case. And in doing so, we applied the framework of think big, start small, and scale fast. The digital colleague workplace is the think big idea. Agentic AI to control the airport. But first, we had to securely lay the foundations before iteratively adding functionality and complexity. It was also vital to find a use case that not only demonstrates the power of Agentic AI, but also solves an immediate business problem for MAG and demonstrates measurable value and return on investment. Well, MAG had identified exactly that kind of opportunity, which Steve will now share with you.
So, the first use case we selected was around unplanned absence reporting. So we're pretty good at forecasting and rostering in the medium term, but there's always these unplanned issues that happen, which means that you need to have real-time re-rostering of staff at any given moment. Now, particularly topical for us, it's a relevant and critical business need, but we needed to ensure that we stayed laser-focused on the outcomes here. So yes, we're building a solution, but it needed to ensure that we were reducing our operational cost overall, and that we were reducing our overtime payments, for example, that we had to continue paying when other staff that were due to come onto shift were unable to make it in at that time. So significant cost drivers that underpinned why this was a particularly pertinent use case for us to select. What does unplanned absence consist of? Primarily illness, which is of significant importance to us around the summer peak, around half-term periods where lots of families go abroad, and also coming up to Christmas. Of course, there are other types of emergencies that also have the same implication, right? Travel, issues with public transport or people's vehicles enabling them to get in, or a family emergency that people have to deal with. So let's just take a look at the current state. There's probably two key things to mention in this. There's the aspect of dealing with the re-rostering of staff. And so that's the top line of the thread. And then secondarily, there's also the pastoral care for that employee that the line manager would need to take care of. So in this instance, we would have an employee calling in. We've got a third-party reporting helpline. The resourcing team would deal with that. Re-rostering would occur, and a replacement would be scheduled. In parallel, the line manager would be informed, and their HR record on our HR database would be updated. Now, that's all well and good for this user group, but as you can imagine, across 3 different airports and different teams, there is a very slightly different process in place, meaning that we wanted to take the opportunity to standardize, but we had to ensure that the outcomes being driven by the solution that we built were accurate and, I guess, provided the same result in very varying circumstances. So what's the value case behind it? I touched earlier on some of the reasons why we selected this as a use case, but the value kind of stands up for itself here. I'll talk you through the 3 points in a second. This is only for this particular use case. Bearing in mind, this is step 1 on a larger journey for us. So the value case for an underlying digital colleague workplace is even greater than this. But the example here for unplanned absence is really centered around reducing the amount of cost on payment of overtime to cover shifts. The quicker we can get people through security, the greater level of spend that they typically have in our terminals. And we also currently pay an amount to a third party in order to provide this service to us. So bringing it in-house was something that was also very, very relevant. Now, all sounds good, doesn't it? But we didn't just want to start charging ahead. There were some very, very real, very pertinent considerations that we needed to make. Alarm bells would probably be ringing across organizations from cyber teams, people teams, perhaps security teams, about how we're going to ensure that we have the right level of security, accuracy of this solution, and reliability. So you can imagine, how are we authenticating the user as they connect to submit their absence? What if it's not them that's calling up because they've been in an incident? How do you secure and determine who would call up on their behalf or use the app or web app front end in order to submit that absence on their behalf? Accuracy. They're rostered for a shift, but how much of a shift are they unable to attend? Does that have an impact on how we re-roster? Does that have an impact on their end of month take-home pay because they've worked less? Reliability. We operate a 24/7 operation across the airports. This needs to be accessible. It needs to be available. It needs to have a low degree of latency. So a summary of those impacts down the left that I've mentioned are the considerations that we had to discuss, ensure we had suitable solutions and mitigations around, because at the core, this is acting over PII data. It's impacting employees' pay, and we're an airport group. We operate over critical national infrastructure. We are subject to an amount of legislation, to an amount of activity that is not equivalent for other organizations. And so that was built into some of the solution design. It informed how we structured our guardrails. It informed how we evaluated how successful the model and the solutions were being. And it also went into determining what our production architecture would look like. So Tom's going to come and tell us a little bit more about why agentic is suitable here, and then we'll dive into the tech.
Great. Thanks, Steve. So why do we think agentic AI is the right fit for MAG's digital colleague workplace? Let's first consider how generative AI solutions evolve with increasing autonomy in the context of MAG's use case. At one end of the scale, we have generative AI assistants, which can take the form of chatbots or tools built for specific purposes, such as document processing. These can help to automate workflows, but require humans to define and execute the tasks. Moving up the scale, AI agents have much more autonomy. They're given goals and focus on achieving outcomes rather than just completing specific tasks. They're able to adapt dynamically under uncertainty, coordinating across multiple systems. For MAG, the unplanned absence reporting use case would fall into this category. Finally, at the other end of the spectrum, we have fully autonomous agentic systems. These systems can not only accomplish the goals that are given to them, but can independently set and execute on goals. These systems are able to coordinate multiple agents with minimal human oversight. Whilst quite rare today, for MAG, this is the ultimate vision for the digital colleague workplace. Now let's take a look at the capabilities of agents that are relevant to this use case. Agents are given goals and instructions and access to a set of tools to use to help achieve these goals. These could be in the form of a data source, such as an employee data system, or access to APIs for taking action in other systems, such as rostering an employee for a shift. Agents are also given access to memory, so they can recall their short-term and long-term interactions with the user for additional context. Finally, agents use their reasoning capabilities to break down their goals into subtasks and form a plan. They take action using their tools to execute that plan, and observe the impact of those actions. This observation may lead to more planning and more action, and so the loop continues until the goal is achieved. Equipped with these capabilities, agents can also interact with other AI agents, each with their own specialized set of goals and tools. This agent-to-agent interaction allows for the creation of multi-agent systems, which is MAG's ultimate vision for the digital colleague workplace. So returning to the question of why agentic AI for MAG's digital colleague workplace, or to ask the question in a different way, why wouldn't we have not just used a simple automation tool or a generative AI assistant for this use case? The airport is a dynamic environment with non-deterministic processes requiring coordination across many interdependent functions. We've already talked about the complexity in the unplanned absence reporting use case. 3 different airports, many different process flows based on job type, and numerous different types of absence, each with their own HR policy attached. And quickly, we're into hundreds of different workflow permutations. For example, being absent due to childcare invokes a different policy as opposed to illness. And this is just one of hundreds of processes that MAG want to bring under the control of this system in the long run. For example, it'll also cover fault reporting and asset management. So what if a staffing decision in one part of the airport is impacted by equipment being out of order in another part of the airport? And what if that's further compounded by a large number of flights being delayed? Agentic AI gives the ability to think through these scenarios dynamically, whereas an automation tool would require programming of hundreds of different workflow permutations and still wouldn't capture all of the edge cases. Agentic AI is also modular and extensible by design, allowing MAG to iteratively add functionality by deploying more agents as they build towards the ultimate vision of the digital colleague workplace. We're laying the foundations for an intelligent airport where multiple different functions can interact together to optimize operations. The flexibility of agentic AI to handle exceptions, where input received from the user is incomplete or ambiguous, is also key to making this work in the real world. For example, what if a user uses colloquial language or misses key bits of information because they're reporting in an emergency? AI agents can use their inherent natural language understanding to engage in a multi-turn conversation with the user until they have the information that they need. Automation tools lack this inherent understanding, can only execute predefined paths, and rarely handle exceptions gracefully. Now, agentic AI is certainly not the right fit for all use cases. If you have a predictable, deterministic workflow, then an automation tool may well be the way to go. However, in MAG's case, the combination of complex non-deterministic processes, the need for extensibility, and high potential exception rates made agentic AI the right choice. So now that you know why we chose this approach, let's see how we built the solution.
Thank you, Tom. So you heard from Tom and Steve why the type of problem that we're trying to tackle here and why we chose agentic AI. Now I'm going to be telling you about exactly how we went about building this solution. I'll be talking about our development journey, how we decided to build each component of our solution, and also I'll be telling you about all the lessons that we learned along the way that informed our implementation patterns. First, let's start with the current workflow. What are we trying to solve here? Okay, so say you have an employee that is unable to come to work. They have an unplanned absence. Say they're ill. The first thing that they do is reach out to a point of contact. This can be a line manager, a rostering manager, someone within the organization that can quickly rely to, whose full-time job is also something else. It's managing other people and other workflows. This point of contact needs to make sure they have enough information about this employee to know who they are and why they're reaching out. They need to know what the relevant HR policies are for unplanned absences. They also need to know what type of absence we're talking about. A sickness absence is not the same as a stuck in traffic absence. Then they need to record this absence into an HR system. and notify all the relevant personnel, so maybe another line manager or someone else. And if this employee is a rostered employee, there's additional steps. You need to record the absence into a shift record system, and you need to notify even more people. So what I'm going to be telling you about is how did we go from this current solution to our target solution. And I know it looks complex, but don't worry, we're going to build it little by little. OK, so first thing, this is our solution. This is the current business workflow. The first thing that we did looking at this is how can we automate each of these steps so that they can be done by a software. So for example, we can connect to an API. We can connect to an HR rostering system with an API call. We can look at HR policies with a knowledge base. We can classify absences through an LLM. And we can notify a manager through Amazon SNS, our messaging solution. Now, let me simplify this a tiny bit. OK. So we started testing this. And instead of having a point of contact, you can have a deterministic workflow because these are all just tools. But this doesn't quite always work. So if an employee comes in and gives incomplete information, then our tool doesn't work already because it can't quite record the full absence. This is why we really need an agentic workflow here. We need a natural conversational pattern that is able to collect all the relevant information from the employee. Now, we can connect this agent to all of these tools pretty much the same way as they were done deterministically before, and give it a prompt that will tell it exactly what it's meant to do. And I know you guys have heard about agents before, but let's make sure we're all on the same page here. Agents go with the React pattern, where given a human input, it would reason, act, observe, and give you a response. So here, our agent is implemented with strands, and each reasoning step is logged in an S3 bucket for observability. And what do our tools look like? So our tools are like this one, for example, which extracts all the information from the user that the agent needs to take the further steps. OK, so we have our first agent. And we were excited. It worked in our demo. And then we started testing it. And we got some unwanted behavior. And we looked into it, and we came to our first big learning. You need to adapt your tools for agents. You will all have tools in your current work streams that are like software tools that already give you the right answers that an agent can use. But agents can be so much more accurate and fast if you manage to tweak your tools a tiny bit. So engineer verbose error catching. Tools, like humans, need to know why an error is appearing. Otherwise, they're not able to find an alternative path to your solution. Make the tools output human readable. Sure, LLMs can understand all JSON formats, but just like us, they're going to be quite a lot faster if you tell them the information that they need to look in these outputs. So if you already know what information exactly you're going to have to extract from it, just do that extra step for them if you can. And then combine sequential tools. This is really important for latency. If you have a sequence of tools that you know that are always going to be called in the same sequence, just do them together. So in our example about extracting employee information, this is the type of output that we want to achieve, as opposed to this, really. So lesson number 1, adapt your tools for agents. OK. So we have our text-to-text solution. Text-to-text solution. We have our first solution, which is reachable by text. And it worked on my laptop. It was great. But of course, not all the employees are going to come to my laptop and play with it. We need scale. What if 50 employees need to use it at the same time? And of course, you can start going down the realm of hosting it on a Lambda, and then you need to think about a WebSocket, state management. These were like weeks of work to make sure that everything would work correctly, how you intended it to work. But then we actually have a really good solution for this that encaptures all of that complexity. And that's Agent Core runtime. OK, so Agent Core runtime solved this in one afternoon. I know you heard about Agent Core quite a bit throughout these past days, but just to give you a quick overview, if you haven't, Agent Core gives you the scale and security to deploy your agents securely. And right now, I'm talking about Agent Core runtime, where you can host your agents. But it comes in a wider ecosystem of tools that Agent Core has built, and a wider set of capabilities that are actually even wider than what I have on the screen right now. But the main reasons why I like Agent Core runtime is because it's compatible with all open source infrastructure, such as MCP servers and various frameworks where you can host your agents. So we are using runtime here with Strands agents, and I'll be talking about the model context protocol that we built with it. OK, and now so we have one employee coming in, a second, a third, and a fifth. Agent Core runtime solves our issue by being a serverless solution that connects directly with the front end and has state persistency, so that each one of these employees gets an answer. So we have a solution that handles conversations with runtime. And now we started thinking about the future. What happens if we expand the scope of this agent? What happens if, in the future, we want an employee that reports something different apart from an absence? For example, a broken escalator. Now we have an issue, because our current solution cannot handle this. So we can either take the solution apart and tweak it and re-put it out. But this is a monolithic approach to this problem. You'd need to make sure that everything is working all over again. What if you can separate concerns? What if you can separate the concern of all of your tools from the concern of your agent? This is why we decided to host our tools on an MCP server. An MCP server gives you a standard way of exposing the tools, which means that not only I can change the tools, but I can also then reuse these tools in a new set of circumstances with a different agent if I want to. And these tools are now hosted in Agent Core Gateway. Agent Core Gateway makes sure that the agent can discover all of these tools automatically. How does it work? An employee comes in with a question to Agent Core runtime, or the agent hosted on Agent Core runtime. Agent Core runtime connects to Agent Core Gateway and searches for the correct tool to answer that question. It then is able to query that tool, get the result, and answer the user's question. Crucially, we can add more tools on the fly. And all of this is through a single API call to Agent Core Gateway. So our working text-based solution was working beautifully in testing. And we took the leap, and we went through our security review. And our security reviewer looked at us and was like, OK, what stops someone from social engineering the agent into doing something malicious? And we're like, yeah, that's a great question. Well, of course, we would add guardrails. So we started adding guardrails, and it worked really well for extreme solutions. But what if a user is a bit sneakier, or if they're trying to engineer a conversation over multiple steps? And keep in mind, here we're talking about an airport. If an absence is misrecorded, this means issues with like checkpoints, flight systems. This has like high impact. So this, of course, without the proper security, this would go through. And it led us to our second lesson. You have to think broader than standard guardrails. Write custom guardrails for compliant and responsible AI. Current Bedrock guardrails only look at the last message that the person has written. When you think about guardrailing, of course, the first thing that you should always think about is the principle of least privilege. Make sure that whatever tool the agent is using can only be used by the person that is authenticated. But sometimes you kind of just need to leave a bit of flexibility to an agent to use multiple tools. In this case, you really want to define unwanted conversation patterns. and build guardrails that have a context of the conversation so that they can actually track that conversation pattern and react in case the pattern is deviating from a standard pattern that you want your agent to interact with. So in our scenario, we added a context-aware guardrail through a Lambda. And this is based on recovering the memory of the agent and having an LLM as a guardrail. Now, we have a microservice-based agent with guardrail. But we still have one crucial component missing. What if Macy, who is in her car, she's driving to work, she's sitting in traffic, and she can't quite make it in time for her shift? What happens then? In our previous solution, she would have picked up her phone, she would have called her manager, she would have been, I'm sorry, I'm late. And this would have all been solved for her. Now, she would really have to take out her phone, open an app, write some text, all things that you really cannot do in a car. Hence, we need a speech-to-speech solution. Here, we built our speech-to-speech solution thanks to Amazon Novasonic. If you're not familiar with Amazon Novasonic, it's a speech-to-speech model that is able to interact with you verbally. Now, speech-to-speech adds a real-time streaming complexity. So Novasonic expects continuous audio input and gives out continuous audio output. And so this can't really go through a request-response pattern like our text-to-text model. So we had to handle this with a WebSocket connection. And this is managed by the ECS, which buffers the audio frames and coordinates the bidirectional stream. Great. So now we have the infrastructure to make sure that the user can speak to Novasonic. But now Novasonic is a model. We need to prompt it. And so we're like, great, we're going to use the same prompt that we use for the text model. And we're going to go to Novasonic, and it's going to work. Let us do our next lesson. Read speech-to-speech model prompts out loud. Speech-to-speech models have actually been trained on speech. And so they can't think as complexly as a text-to-text model. Don't rely on chain of thought. No human will actually tell you what it's thinking about before actually saying it. Write out enumeration patterns. These are great on a text prompt to give an idea to the model on what you're about to do, but no one enumerates their sentences when they speak. And think about spelling. Your model, just like you, might not know all the names of all the different nationalities that are around you, so help the model think about how to deal with these edge cases and situations. So read your speech-to-speech model prompts out loud. So we did this. We redrafted our prompt to be more speech-based as opposed to text-based. And then we had our model that connected to our user, for now through a front end, but in the future through a phone line. And now this model needs to connect with all the tools that we built for the text-to-text model, which led to a bit of a concern because, as we just said, you want a speech-to-speech model to interact with a verbose answer, like something that you can read out loud. And all of these tools are mainly like software outputs. Yes, we've improved them a tiny bit with lesson number 1, but they're still mainly like systems. But then we had an aha moment. There's a part of this infrastructure that is already trained to give you a human-readable response. And that's your text-to-text model. That's the agent, the text agent that we built as the initial solution, the written solution. So instead of connecting Amazon Novasonic directly to the tools, we connected Amazon Novasonic to the text agent that we had already built. Like this, we have an agentic hierarchy where Novasonic calls as a tool the text tool, the text model that then calls all the tools. And this also solves other problems that we would have encountered. Instead of having two sources of truth about how to use these tools and how to think about these problems in the text and in the speech-to-speech models, now we can just keep it in the text-to-text model and leave the speech model to just know when it has to call that tool. And this is great, but we still have a crucial concern, which is if you're calling the model, then you're not authenticated. If you're using a text-to-text model through an app, you're usually authenticating before you get exposed to that model. But here we had an authentication problem. So we built an authentication tool. We asked Navasonic to collect all the relevant information from the user and then pass it to an authentication tool that would compare this information to the information stored in the HR system and return an answer on whether or not that user gave the right information and could be authenticated. After which, Navasonic was allowed to use the text-to-text tool. So think about your authentication with speech-to-speech models. OK, so here it is. This is the full architecture, our agentic AI solution for unplanned absence reports. So we got here, and we demoed this to our business stakeholders. So we showed them the architecture. We showed them a demo where a person would come in and be like, they're sick, they can't come in. And as expected, our agent started by authenticating the user, categorizing the absence, recording absence with the HR system, notifying the managers. And all this while, the employee was getting no response. And it got to this point, and our business stakeholder was like, oh, is it frozen? Lesson number 4, and perhaps the most crucial lesson. You can have the most amazing backend that can do all the most amazing tasks. But agentic still requires an agent to go through a set number of tools, which actually will always take some latency, which will always feel too much for an end user. And UI is king. You need to keep your user engaged. So you need to add intuition on what the agents are doing behind the scenes, while keeping this high level enough so that you're not revealing all your infrastructure in the backend. UI is king. So what does this look like? Let me show you this in action. So this is our UI. We have a person coming in, say that they can't come into work, and they give you a good reason why. And the agent starts processing this information, retrieving all the user information, then classifying the type of absence that this user is coming with, and then realizing it doesn't quite have enough information to fully record the absence. So it asks for more information that the user then provides. And then the agent is back to work, figuring out what day it is, when is the person coming back on the calendar, and then creating all the records of absences. In this case, the user is a rostered user, so we need to record both the absence into an HR system and the rostering system, and notify both their manager and their rostering manager. And then also making sure that the user is aware of what has been done behind the scene. So it also sends a message to the user about all the tasks that have been done. So this is it, our solution. So our key takeaways are 4. The first is adapt your tools for agents. Make sure you use verbose error catching and minimize consecutive tool calls by merging them. Second is write guardrails for multi-turn conversations. Make sure that your agent cannot be strayed away from its intended use. The third is read your speech-to-speech model prompts out loud. And the fourth is UI is king. Keep your user engaged. So how did this work for us? Well, we managed to standardize the way the absences are recorded in the system. And we now have a 99% consistency in absence reporting. This is unleashing a lot of potential into analyzing what the patterns in the absences are downstream. And we also reduced the time it takes for recording these absences by 90%. But I'm going to let Steve tell you more about what's in stock with MAG for the future.
Thanks, Margarita. So that's just a small window into, I guess, what we've achieved this time round. We are well on our way to becoming or achieving our strategy, which is to become the world's most intelligent airport group. You can obviously see what some of the next steps are, right? So why not automated rostering? Think about the operational side of the airport, spinning up certain bits of the terminal depending on which stands are going to be used or not when they're out of use. There is a whole stack of more use cases that we intend to apply this to. It will ultimately result in us having more agents with the right level of humans in the loop, a great number more tools that we're leveraging, and ultimately a more autonomous, efficient, and effective airport.
Great, thanks, Steve. Margarita and I are part of a team at AWS called the Generative AI Innovation Center. The QR code on screen will take you to our homepage. We're a builder team that support AWS customers in building generative AI solutions to their problems. If what you've heard today resonates with you and you'd like to discuss building agentic AI with us, please do get in touch via your AWS account manager. And now, as we bring this presentation into land, I'd like to thank you all very much for your time today. Please do remember to complete the survey in the mobile app. And if you have any questions, we'll be available afterwards, but outside the theater. Thank you.